Let's go to page 559. Start with number 1. It says Jane is finding a plane on a triangular course. Okay, so let's do that. So let's get a coordinate. So this is the east, and this is the north, south, and west. Okay, so the speed, the r equal to 300 kilometers per hour. So she flew due east for 2 hours. So if it's 2 hours, so 2 hours, this will give you 600 kilometers, right? Because 300 kilometers per hour, so 2 hours will give you 600. Then she turned at a 75-degree angle. So this will be 75-degree angle. And so she will keep going. And so how long after turning, so you're looking for the time over here, okay? Which should be exactly northeast. So northeast, that means this would be 45 degrees, okay? So northeast is exactly halfway between north and east. Okay. Okay, so from here, we can go and look for all the angles first. Okay, so this is the supplementary angle. So to find this angle, just use 180 minus 75. This will give you 105 degrees. And this angle equal to the sum of these two angles, so this will be a 30, right? 30 and 45 will give you 75. Okay. So first, to find the time, we need to find the distance first. Okay, so let's go and call this x. So once we find x, we can divide by that to find the time. Okay, so from here, we can use a law of sine. Okay, so this facing this, so x over sine of 45 degrees. So this facing this will equal to this facing that, so it's equal to 600 over sine of 30 degrees. Okay. Okay, then go ahead and times by sine of 45 degrees. Sine of 45 degrees, so this will cancel out with this. So x will equal to 600 sine of 45 degrees over sine of 30 degrees. So get your calculator and enter all the information. So 45 sine times by 600 divided by 30 sine equal, so x equal to 848.528, okay? And this would be kilometers. Then what we need to do to find the time, okay, so if you remember, r times time equal to distance. So to find time, you have to divide by the rate. So time equal to distance divided by the rate, okay? So time equal to the distance, so it would be 848.528 divided by the rate r, which is 300, okay? And so you will have here, so don't erase, don't reset, okay? Just use that number divided by 300, and this will give you t equal to 2.83 hours. Okay, and that's it for number 1. Okay, let's go to number 3. Okay, so you have a television antenna standing on the level ground. It's supported by 2 cables extending from the top of antenna to the ground on opposite side of the antenna. Okay. Okay, so one cable is 300 meters long and make an angle 48 degrees with the ground. Okay, and the other cable is 270 meters long. Okay, find the acute angle that second cable make with the ground. Okay, so you're looking for this angle right over here. I'm going to call it theta. And the distance between the cables at the ground. So you're looking for this distance over here. I'm going to call that x. Okay. Okay, so this one, since this is straight on the ground, okay, standing on the ground, so this one you actually make into a right triangle, so you can use a sine, cosine, and tangent. Okay, so it's a lot easier. Okay, so to find this, we can use, well, okay. So you can use, also you can use, to find this angle, you can use the law of sine, okay? You can do that. Okay, let's go and do that, and let's go and look for the theta. So this is facing that, this is facing that. Okay, so let's go ahead and look for, let's get this angle first. So sine theta, so this is facing that over 300 equal to sine of 48 degrees over 270. No, not degree, just 2 centimeters. Okay, then you multiply by 300. So this will cancel out. So sine theta is equal to 300 sine of 48 degrees over 270. Okay, so get your calculator, enter all the information. So 48 sine times 300 divided by 270 equal, so sine theta equal to 0.8257, and you go second sine. So angle theta equal to 55.66. Okay, and so I'm going to run it off to 7. So 55.7 degrees. So that's your angle theta. Okay, so this is equal to 55.7, well, I'm going to put 66 degrees. Okay, when I do calculation, I'm going to be more exact. Okay, but when I put down the final answer, I can run it off. But if I'm using it to calculate, I want to carry more digits. Okay, so 66119. Okay. Okay, so now we're going to look for x. So what we can do is, in this case, we can use the law, use the sine, cosine, tangent, because this is a right triangle. Okay, so I'm going to call this, just going to call this a. I'm going to call it x1, okay, and call it x2, okay, and this is the total x. Okay, so this will give you the cosine function. So you write down cosine of 48 degrees equal to x1 will be adjacent over hypotenuse, right? So cross multiply, so x1 like cross multiply equal to 300 cosine of 48 degrees. So x1 equal to, so 48 cosine times 300 equal, so x1 equal to 200.739. I can carry extra digits for now until you rate for the final answer. Okay, then do the x2. So again, this would be, so cosine of 55.66 degrees will equal to x2 over 270. Okay, again, right triangle, so you can use sine, cosine, tangent. Okay, so cross multiply, so x2 will equal to 270 times cosine of 55.66 degrees. So enter your calculator. Okay, so I got 55.66119. I preserve the number over here. So I want to enter extra digits to just to be more accurate. So cosine of that times by 270 equal will be 152.303. Okay, so now x would be just these two adding together, right? Okay, so I'm going to add this with that. So again, I have this number, so I'm not going to erase. So plus 200.739 equal, so x will equal to 353.04. Okay, and if you run it off, now this is kind of pretty close. Since there are 3 digits, so I'm going to run it off to 3 digits. So x equal to 353 meters.